As more and more data comes in, it just cements the position that there is no plausible naturalistic explanation for the formation of stars, galaxies or planets. In all the exoplanet discoveries made, nothing even remotely close to an Earth has been found. All that we observe is consistent with what Genesis says, that God created the heavens and the earth.
It seems from news reports that signs of life have already been found in outer space. Can you tell us what have they found, and is that a sign of life? Mark, most of us learn about the solar system planets that orbit our star, the Sun, at school. But when we look at the night sky, there's thousands of stars there, and we know there's much more than that. There's actually trillions and trillions, maybe countless stars there. So the question comes to mind, are there planets that orbit those stars? Now, you've got 3 degrees, one of them in radio telescope and antenna design. Can you answer this question for us? The stars we see in the distant sky, are there planets orbiting them?
Well, there most likely are. In fact, it was thought that, or suspected that there were planets orbiting other stars many, many years ago. But it's only been in the last, say, 30 or so years that the technology has developed to the point where we're actually able to observe them.
You say the last 30 years. When was the first discovery made of one of these planets, and what are they called?
Well, probably in the early 90s.
Yep.
And they're called exoplanets, meaning that they are planets outside of our solar system.
That makes sense. Exo,
outside of, that's right.
So men landed on the moon in 1969. What took us so long to find exoplanets?
Well, exoplanets are actually very difficult to see. For a start, they're quite close to the star they orbit, and the planets themselves don't actually emit light, they simply reflect it. So they're way, way dimmer than the star, which is very, very close to them. So, as I said, it's only been in the last 30 years that the technology has existed to be able to detect the presence of exoplanets. And the results have been absolutely startling.
Wow, so the idea is we've got this star that's very bright, and close to it is a planet that's less bright. And so it's trying to have the technology to block the star light out. Is that kind of how it works?
Partly, and also to find variations in the light coming from the star that would be a telltale sign that there's something orbiting that star.
Got you. So as the planet goes in front of the star, then the light from the star might dim.
That's right. That's right. A certain percentage of them we will see edge on. So you can imagine the planet passing between us and the star, therefore blocking some of the light from the star. So the light intensity dips briefly as the planet passes by, and you notice a periodic pattern like that. So it's a logical conclusion that there's something orbiting the star. More recently, with the new James Webb Space Telescope, there have been efforts made to try and measure the nature of the atmosphere around some of these exoplanets.
Wow, that sounds even harder.
It is.
So hopefully we'll get onto that later. I've got a few other questions for you now. How many exoplanets do we know about?
Well, as of today, around about 5,000 have been detected and confirmed. Now, it's one thing to detect, but then you have to confirm that that detection was in fact a valid detection. About 5,000. So that's a good sample, a good collection. So we've got a fair idea of what these different systems of planets look like.
And so it seems like from the news articles that scientists are very keen to find more exoplanets. Why is there this interest in exoplanets? I mean, I get they're kind of naturally interesting, but can you explain more? Why are they so keen to find more exoplanets?
I guess in the secular community, there's a belief that the universe came about by chance, that life originated on our planet by chance. And so if that's true, it's not an unreasonable assumption that maybe life has arisen by chance on some other planet. So the motivation really is to find out, are we alone? Are there other life forms out there? So it kind of looks to verify the assumption that everything happened through natural processes only, or at least to confirm that view. So there's a real strong push to see if there's life elsewhere in our universe.
Got you. So you're saying if we found life elsewhere, or if there were other planets that were like our Earth, then it's kind of saying, well, I mean, that life on Earth is random. I guess if you come from the presupposition that we are randomly here by accident,
that's right,
then surely that accident must have happened somewhere.
Must have happened elsewhere. That's
in the
right.
universe.
That's right.
Okay, so would you say a prediction of the naturalistic worldview would be that we will find a habitable exoplanet with life on, and a prediction from the biblical worldview would be that we won't? Is that fair?
I think that's a pretty fair summary.
Yeah.
So there's a lot invested in trying to demonstrate one way or the other, are we alone or not in the universe? Yeah. In fact, the first space telescope that was dedicated to the search for exoplanets was called the Kepler Space Telescope. And part of the mission for Kepler was to determine how common Earth-sized and larger planets are in the habitable zone of Sun-like stars. So very clear emphasis, how common is it? Is our Earth really that special, or are we just a common or garden, run-of-the-mill kind of planet that you just find anywhere? Scientists have recognised, of course, that there are many, many factors necessary to sustain life. And one of them is the existence of liquid water. So if a star is very hot, for instance, and a planet is close to it, then the planet will be hot and liquid water probably won't exist. It'll just boil away. If the planet is too far away from its star, or if the star is very dim, then any water that might be present would be frozen. So there's a sort of zone in between where liquid water can exist on the planet. And that was the initial broad brush definition of what habitable zone meant.
Interesting. Okay, so they've got to have liquid water on the surface. And why is that? Is life possible without liquid water? I guess, do we know?
Well, we don't know of any life forms that exist without liquid water.
Yeah. And so how rare have they found that? Is the Earth the only planet with liquid water on?
Well, no, we've found planets in our own solar system where there's evidence that there has been or is water. But in exoplanets, that is still yet to be confirmed.
Yeah, yeah. And within our own solar system, is there any? I don't think is there any liquid water on the surface that's been found? Because I've seen reports of Encelades and these different moons and even Mars having water, but often it's in the ice caps or it's below the ground. So I'm wondering, is liquid water on the surface? Is that it? That seems to be a big goal. Yeah,
to date, there's no evidence of liquid water on the surface.
Yeah.
But lots of evidence of water, usually frozen.
Yeah, water throughout.
Or subterranean, yes.
So going back to the exoplanets, has there been any that have been found to be, I've seen in news reports, Earth 2.0. So there's claims that these exoplanets are like the Earth. Now we're saying, okay, they don't have liquid water on the surface maybe, but maybe they got ice, maybe they got liquid water under the surface. Are they similar to Earth in other respects?
Well, some of them are rocky planets, like the Earth is rocky. It seems unlikely that life could exist on a gaseous planet. There's nothing for it to exist on. But there has been no Earth 2 found. Had there been, it would have been all over the headlines. You'd hear the celebrations globally, I think. But nothing has been found that's really close to our Earth. Now, similar Earth-sized planets, and you often see that now in the headlines, Earth-sized planet found and so on. But being around the same size is a far cry from being habitable for life. So there are many, many factors which have to fall into place for life to be able to exist.
Interesting. So we were talking about the habitable zone earlier, and we were saying that, okay, it needs to be the right distance away from the star for the temperature to be right for liquid water. But what you're saying is there's a few other requirements. You mentioned a rocky planet. It can't be a gas giant. Can you just talk a bit more about that?
Look, it's interesting. I suppose the best way to describe that is to look at some of the properties of our own planet. For a start, our planet spins on its axis, which has the effect of distributing temperature around the planet. We're not what's called tidally locked to our star, and that means that the planet is gravitationally locked to the star, so the same face always points to the star. An example of that would be our moon. That's tidally locked to the Earth. So from Earth, we only ever see one face of the moon. So if our planet was tidally locked, then one side would be exposed to the heat of the sun permanently, The other side would be in darkness permanently. So that would be extremely inhospitable. So the fact that the Earth spins at a rate of once every 24 hours means that there's a good distribution of temperature. So that's conducive to life. Lots of other factors. The Earth's axis is tilted, so we enjoy seasons in a regular pattern, and that is essential for biological life on the planet. And look, the list goes on.
Yeah, I guess just thinking about the seasons and the spinning, so you get the day and the night, means that it's not going to keep heating up in one part.
That's right.
And keep cooling down in another part, and then that might accentuate over time. So that's interesting. So we're saying that actually the habitable zone, if a planet is in the habitable zone, it doesn't necessarily mean it's habitable.
That's right.
Yeah.
Yes.
So
yes.
all it's saying is it can have liquid water there. But what you're telling us is there's a few other requirements for habitability.
Absolutely. You need an atmosphere. There's another one.
Right, interesting. So the Earth has an atmosphere, right?
We have an atmosphere, and a lot of the exoplanets that have been found don't.
Interesting. So would that be like the moon or Mars? They've got very thin atmospheres or zero atmospheres?
Basically zero, that's right.
Yeah.
That's right. And that's partly because some of the stars that these exoplanets orbit are very unfriendly. Now, we have a very friendly sun. It's extremely stable. It's the right size. It gives out the right amount of heat intensity for our planet. But some of the stars that exoplanets orbit are very violent, with massive flares, ultraviolet radiation. Any atmosphere that might have been there has been ripped away long since.
Right, interesting. So I actually saw some studies on that saying the sun is not only is it a G-type star, not only is it in the main sequence in the right place for it to be stable, but even when you compare it with other stars of the same class, it's still reliable. But the papers I saw were not saying the same thing as you. I'll just find this one here. This isn't a paper, this is from a news site. It says, astronomers prove our sun is lazy and boring compared with other stars.
Interesting spin, isn't it?
Yeah, because what would you say?
Well, I would think that it's an example of amazing design. For our sun to be like that is indeed unusual. Stars about the same size don't behave like our sun.
Yeah.
So if it was like others, then life probably couldn't exist on this planet.
Yeah. So there'd be more X-ray flares, solar spots, all these big mass ejections and things like this. That would not be very helpful for life. And you were even saying it would sometimes strip away the atmosphere.
That's right.
Gosh.
That's right.
So we can be thankful that we have a stable sun.
Absolutely.
Yeah.
The sun is in fact not a common or garden star at all. I have a little telescope at home that I like to get out very occasionally, show the grandkids the stars,
Cool.
And in the manual, it talks about our sun and our planets, and it says the solar system is an ordinary solar system with ordinary planets. But that's extraordinarily misleading. Indeed, it's not ordinary at all. It's quite extraordinary, as our discoveries of exoplanets are revealing.
Interesting, because we wouldn't have known about this before the 90s because we didn't know about these exoplanet systems. So, can you tell us a bit? I guess the formation of the solar system in the naturalistic worldview would be, or the way solar systems form in general, the way planets form, would be based on our own solar system. But with the findings of the exoplanets, has that changed the idea about how planets form and how solar systems form?
Well, the secular model for how solar systems form, of course, doesn't entertain the prospect of a supernatural creation. So they have to rely upon naturalistic mechanisms to account for the stars and for the planets orbiting them. And so what was expected was that as more and more information was revealed about exoplanets, it would simply confirm the then accepted model, which was, in rough terms, you have this cloud of dust and gas which is swirling around. It condenses down to a star at the centre, which, as it gets more and more mass and is compressed under the forces of gravity, the nuclear reactions begin and it starts to burn and radiate heat and light. And then following on from that, various parts of this rotating disk condense to form planets and further out. And people thought, we had this pretty much nailed down. There are a lot of problems with it, of course, and there were no really acceptable or working numerical models that would give a holistic view of this process, but it was the one that was promulgated as the standard. So when the data started to come in from exoplanets, it was found that the model just simply failed to describe what was being observed. And it sent astronomers and cosmologists basically back to the drawing board.
But with most of the other solar systems, most of the other exoplanet systems, were they not very similar to the solar system? Or were there just a few that were very different and therefore the model could still be okay? Or?
Well, nothing was found like our solar system.
Right.
So has been to date.
We have a unique solar system.
Out of the 5,000 that have been identified, that's a fairly big sample.
5,000 exoplanets.
5,000 exoplanets have been found. Many of them in systems of planets,
yes,
and none of those systems look anything like our solar system.
Wow.
There's just no correlation.
Yeah.
To the point that astronomers are really basically saying we have to go back to the drawing board. We've got to come up with a whole new model for being able to understand how these things happen on a naturalistic basis.
Yeah, interesting. Now, I've heard that the moon is quite useful for life on Earth. In fact, it's very important. Now, can you tell us why is that? And have the exoplanets, do any of them have moons that are also useful for life? Or do they need a moon? Yeah.
Well, our moon is really an enigma. It's very interesting. It's a very large moon. It's about 1/80th of the mass of the Earth. If you look at the other moons that we know about in our solar system, typically they are much, much smaller. And most planets that have moons have a lot of moons. Jupiter, for instance, the count is now somewhere up near 100. They keep finding more and more small moons.
Wow.
Saturn has a large number. I'm not quite sure where it's up to right now, but it's many tens of moons. We have only one, and a very big one, and it has a very significant effect on life on Earth. And of course that's in multiple ways, but the most obvious is in the generation of tides. So the ocean tides constantly circulate and oxygenate the coastal waters so that life can thrive. And that's essential for many interconnected ecosystems. So if the tides were not operating as they do, then life would be much less likely on Earth, or much less, the environment would be much less livable.
Right.
But the moon is also an enigma because no one has an acceptable model for how the moon came to be. Now, that's interesting because this is the closest astronomical body to our planet.
Yeah, surely we should know the most about the moon.
We would have a good idea, wouldn't you? But we've got no idea.
Ah.
There are various models that have been put forward. They've all kind of been discounted. One of the motivations, in fact, behind the Apollo space missions was to sample rocks on the moon, bring them back for tests and so on, in order to find out which of the then current theories was likely to be the right one. And all three turned out to fail. So the fourth one, current now, is that it's the result of a collision with a Mars-sized object called Theia, which would have happened somewhere in the early so-called molten stages of planet Earth.
Wow.
But it doesn't really work either.
Billions of years ago, I assume.
Oh, yes.
Yeah,
yes,
wow.
yeah.
And what kind of evidence do we have for that? Like what evidence is used to support that theory?
Well, probably the fact that it's there is the best evidence.
Right, okay, yeah.
And the other best evidence is that the other three models failed, so it's the only one left standing.
Yeah.
But the evidence that is observed really doesn't support the theory well at all. The orbit dynamics for the moon are wrong for that model. The fact that there's only one moon is a mystery. Why aren't there multiple moons as a result of that collision?
Yes.
And the list goes on. The geochemical formations of the moon are not what you'd expect. There are volatiles on the moon which would have boiled off in the heat of the collision. So how come we've got those things on the moon? There's an extraordinary similarity between the geochemical properties of moon rocks and Earth rocks. You would think that there'd be much more influence from the colliding object, Theia as they call it, but there doesn't seem to be, unless it too had the same geochemical properties as the Earth, but that's a very long bow to draw.
Yeah.
But the Moon is sufficiently different to discount the possibility that the Moon was formed by a chunk of the Earth spinning off in its early formation stages.
Right.
So it's an enigma.
Yeah, really interesting. Something I just make so it's clear for everyone. One of the things you were saying then was about the volatiles on the Moon, and they should have burned off. So a volatile is, can you explain what a volatile is and why that should have not be on the Moon anymore?
Well, the presence of water, for instance, you'd expect water just to boil away, vaporise.
Once you have this big impact, there's a lot of heat, so it should boil away, but it hasn't, it's there.
Yes.
Wow. Yeah. So we find water on the Moon, locked in minerals, I guess, and also maybe ice. I don't know, is there ice on the Moon?
Well, apparently in the shaded areas of some of the areas near the poles of the Moon where they never see the sun, there is, there's evidence of ice.
Yeah, of course, that would be a problem, what we were talking about earlier. It's got the locked face.
That's right.
What did you call it again?
Tidally locked.
Tidally locked. So it's tidally locked, and so you got the problem of it being really too cold on one side and too hot on the other side.
Yeah.
Yeah, interesting.
I used to think that, I was mystified. How could the Moon's spin rate be so exactly locked into the orbit rate?
Yep.
Surely over time there'd be some drift.
Right.
But in fact, it's a mechanical locking process.
Yes.
So it's because of the fact that the Moon is deformed from being spherical by the Earth's gravitational field, that it's actually like a football, slightly, like an oblate spheroid, the technical term. So if the Moon tries to turn away from being tidally locked, it gets actually physically pulled back. So it is a mechanical locking system. And that's what you would expect to happen over time with rocky planets or any planets that are close to the stars that they orbit. And that's one of the issues about finding the habitable zone for an exoplanet.
So the issue is there are some that are tidally locked, and that is not good for life.
Yes, absolutely.
Yeah. I've got a few more questions to ask you about exoplanets. But now I'm going to move to a rapid fire section where I want to ask you a number of questions and I want you to answer them in 60 seconds.
Sure.
So I'm going to give you a timer so you can answer it in that time. And I'm going to go with the first one starting now. How does the Genesis account of creation help us interpret the exoplanet data?
Well, I think it tells us that firstly there is a creator, God, who has created the universe as a home for man on this planet, obviously. It tells us that our solar system is uniquely and especially designed. It tells us that this creator has created the heavens to display his glory to us. And in fact, one of the psalmists said that the heavens declare the glory of God. And how true that is. We see the most extraordinary variety of stars and exoplanets and galaxies and so on that are just amazing. It bears no relationship to any attempt to model these things in a naturalistic way. The heavens do declare God's glory.
So, next question now for you, Mark. What's so special about Earth?
Oh, many, many things. Our planet orbits the sun in the habitable zone for a start. We have liquid water, vital for life. But not only that, ice and water vapour can exist as well, so it's an amazing combination. We have a spin rate that regulates the temperature. We have an axis tilt that provides a regular pattern of seasons. We have an atmosphere which contains enough oxygen for us to be able to breathe, but not too much that the atmosphere is highly combustible. We have an abundance of water on the Earth, and water is very special. It expands on freezing so that you have water underneath ice so that marine life can survive the coldest of winters. It's just it has a magnetic field that protects it. The list goes on and on. We really are in a Goldilocks planet.
You said that Earth is fine-tuned for life, Mark. What do you mean by that?
Well, let me share a quote that I think sums that up very well. And it's like this: Mercury and Venus are hot and sterile. Mars is a toxic wasteland, and so on out. In between Venus and Mars lies this amazing blue jewel called Earth, blessed with water, greenery, and life in almost every cranny and nook. It has the right magnetic shield, the right solar energy, the right continental minerals, the right atmosphere, the right carbon, oxygen, water, nitrogen cycles, and a moon that is at the right distance, density and orbit. Everything is just right. So Earth is often called the Goldilocks planet.
So it's not just in the Goldilocks zone, it's actually Goldilocks everywhere.
Everywhere.
Yeah.
In every aspect. Mm.
Okay, ready for the next question now? So I've got it on authority here that you believe that there'll actually be an Earth 2.0. What do you mean by that?
Well, Scott, the Bible tells us that this existing earth and heavens will be replaced at the end of the age, because God created a perfect world right at the beginning. It's been marred and damaged by our rebellion against God, called sin. But God is coming, or Jesus is going to return again and usher in a new age with a new heaven and a new earth. And that will again be a perfect place. In fact, it'll be even better, because it will be impossible for sin to ever arise again. And if you like, you might call that Earth 2.0.
Wow, that sounds better than what the exoplanet researchers are promising us. This is an interesting question, Mark. It seems from news reports that signs of life have already been found in outer space. Can you tell us what have they found, and is that a sign of life?
Well, they haven't actually found signs of life so much as chemicals which are found in life, for instance, carbon and so on. There was a case some years ago where a meteorite, which apparently came from Mars, was found to have evidence of microbial life. This, by the way, was later debunked, although that wasn't on the front pages, as is often the case. But there are insurmountable barriers to trying to progress from raw materials to something as complex as a self-replicating living cell. So even if the raw materials were found, that's definitely not evidence of life in outer space.
That's great, yeah. So the chemicals are there, but chemicals are not life.
That's right.
Yeah,
that's
great.
Right.
The James Webb Space Telescope is revealing some fascinating information and pictures. Do you have any predictions on what else it will reveal about our universe?
I think that the more data that comes back, the more images that come back, the more we will see evidence that is consistent with the Genesis account of creation. And it will totally confuse the secular community. All the models that they have for star formation, galaxy formation, the evolution of the universe will be found wanting, because it will conflict those theories. And the simple reason is that the naturalistic theories exclude the possibility of a supernatural creator. And we know from the Bible that God created the universe to declare his glory.
Yeah, that seems like a sensible prediction, because it sounds like it's doing that already in some respects.
Absolutely.
What data did they expect to see from the JWST, that's the James Webb Space Telescope, to confirm the Big Bang Theory? And were they right?
Well, it was expected that the James Webb would find evidence that would confirm the naturalistic model for galaxy formation and star formation. And in particular, very early galaxies should not have any significant structure. They would not be very massive objects, simply because gravity would not have had enough time to have worked on those initial materials. But what was found was completely the opposite. Massive galaxies, way too big, were found that were highly structured, which is totally contrary to anything that was predicted.
What perspective does the vastness of such a huge universe bring to us as humans and our place in the universe?
Well, the vastness of the universe is phenomenal. It's incomprehensible to our minds, really. And I think that shows us how great God is. Awesome in his power, awesome in majesty, and importantly, though, how much he values us. The Bible says that we are made in God's image. So the whole of the universe is made as a home for man, but a home that points mankind to his creator. And I think the message there is that we are the pinnacle of his creative effort, and we need to worship him for who he is.
That's great. And my last quickfire question, starting now. When did God create exoplanets?
Well, the Bible tells us in Genesis chapter 1 that God created the sun, moon and stars on the fourth day of creation. And when it says stars, it basically means a bright object in the skies. It would include planets of our solar system, galaxies and comets and so on. And it must also include the exoplanets orbiting other stars. So the Bible's very clear. It was day 4 of the creation week, a week of miracles proclaiming God's glory.
Do you think it's possible that we will find life somewhere else other than Earth, or is that totally impossible?
I don't think we will find sentient life elsewhere in the universe, because the Bible tells us that we alone, human beings, were made in God's image. And most importantly, not only did Adam have a body, but God says in Genesis that he breathed his spirit. And so we have a spirit. We're unique. We're not just highly developed animals.
Yes.
Human beings are made in the image of God. No other creature in the entire universe has that privilege of being made in the image of God. So
Yes.
I don't believe there is any other life for theological reasons. But the evidence that we're finding through the disciplines of astronomy and so on are confirming that.
Yes.
In all the exoplanet discoveries made, nothing even remotely close
Yes.
to an Earth has been found.
Yeah. And so if we found a microbial life on the moon or a Martian meteorite, the likelihood is that probably came from the Earth itself. Is that right?
That's probably what you would conclude.
And how
but
would
even
that...
if there was microbial life, that doesn't necessarily change the view that I have, because I'm talking about sentient life here.
Yes, yes.
Self-aware,
Yes.
able to think,
Yes.
and so on.
So a lot of people like to think of aliens as being a possibility. And sometimes even Christians will say, okay, aliens are a possibility, and maybe God created sentient life on other planets. But you seem to be touching on that theologically this isn't possible. And how does that relate to Jesus and the gospel? And does that somehow give some information that precludes this idea of sentient life on other planets?
Well, I think it does theologically, because the Bible tells us that it was Adam's sin that brought the whole of the creation into the bondage to decay. And everywhere we look in the universe, we see things are running down, and that's evident everywhere. So let's imagine, for instance, that there was some sentient life on the planet Zork or whatever.
Okay.
These poor beings are now subject to suffering and death and decay because of the sin of somebody called Adam on a remote planet they've never heard of.
Right.
It hardly seems just of God to do that.
True, yeah.
So, and the Bible says that Jesus came to redeem the descendants of Adam. It's because of the first Adam's sin that the last Adam came to pay the price. So any sentient life that was not a descendant of Adam would be outside Christ's sacrificial sacrifice. They are therefore beyond redemption.
Gosh, so when Jesus comes again and this whole earth's burnt up and we get a new one, they're just going to be burnt up.
They're just, if they exist, which I don't believe they do.
Yeah.
The other way of looking at it is that the Bible says Jesus is coming for his bride, and he's not a polygamist with lots of wives. He's coming back for one only bride. And that is the company of all people who believe that Jesus is indeed the Son of God and have been born again.
Okay. Wow. Yeah, this seems pretty definite from a biblical perspective that we're not going to find this sentient life. And so what you were saying is, from a biblical perspective, there's nothing that rules out possible microbial or simple life on other planets, but there's also nothing that points towards it. Would that be correct?
I think that's a fair comment, yeah.
And you're also saying from the evidence we've seen so far, it doesn't look like there is any other life on other planets. And when you look at what we've been talking about so far, actually, we were talking about exoplanets, but really the study of exoplanets is kind of like the study of the Earth, because it shows you how unique the Earth is when you see how different the other planets are.
Absolutely. It just puts it in such a stark contrast.
Yeah.
And as more and more data comes in, it just cements the position that there is no plausible naturalistic explanation for the formation of stars, galaxies or planets, that all that we observe is consistent with what Genesis says, that God created the heavens and the earth. And on day 4, he made the sun, moon and stars.
Brilliant. Thanks, Mark. Thanks for your time today.
Thank you.